Hello and welcome to this course on engineering mechanics, which deals with statics and dynamics. We're going to keep our focus on the two words engineering and mechanics. Let's talk about mechanics for a moment. The laws of mechanics, as we know from high school physics, are attributed to Newton, who published them in the 17th century. But the engineering applications of those laws were not realized until Leonard Euler formulated the Euler's laws of motion, which relate to how rigid bodies move. So let's take a look around and see where rigid bodies are observed and moving rigid bodies are observed. So a quick glance around you will tell you that pretty much everything, starting with the chair you're sitting on, can be modeled as a rigid body. It's a static system, but we want to make sure we understand the forces that are generated by the act of a human being sitting on a chair. A bridge is an even bigger engineering example. There are several such examples. Look around a warehouse that you may have passed through and look at the roof. The truss that holds the roof up is another example of a static structure. Friction is another force that is a very interesting force. We'll look at what friction is, how it can be modeled, and we'll look at examples probably going as far back as the construction of the pyramids, where friction played a great role in having those structures around us now. Coming to dynamics, we'll look at moving objects which are rigid, non-deforming in a sense, and try to understand the motion firstly, and then subsequently look at understanding the dynamics, the forces causing the motion. So we all have memorized the Newton's laws by now from our high school physics, that you require a force, a push or a pull, to cause motion to happen. So we'll look at what happens when such pushes, pulls, torques, which are rotating pushes and pulls in some sense, are exerted on a body. And the reason these are important is to understand where the moving bodies would encounter forces large enough that would cause them to not sustain them, and B, look at understanding motion in the context of what it needs to do for us to benefit from it, and that is the engineering aspect. If you want to gain a deeper understanding of these Newton's and Euler's laws of motion, register for the course, and at the end of it you should have a grasp on these fundamental concepts. Welcome.